right, I think we can start. So, welcome everybody to today's episode of Battery Spotlight. I'm really happy that so many of you joined us again. And for those who are new, let me briefly introduce you to the format. So, we started this format almost 2 years ago now. And we started this format with one goal. We wanted to help the companies to get visible with their innovation. We wanted to give them a chance to spark interest for their innovation. And we wanted to help them connect with others, with potential partners, to finally, then at the last, on the final step, to start working together, starting projects, forming corporations. And so that this event becomes one puzzle piece to transform the individual battery ecosystems we have right now in Europe to form one European-wide ecosystem. We know it's only a small puzzle piece, but I think an important one. Let me shortly introduce myself. My name is Maximilian Wagner. I'm the network manager of the TraWeBa project, which is a German battery cluster. It is funded by the German government with the goal to connect the companies alongside the battery value chain with each other and also with companies outside of Germany, all the companies we have in Europe. And I'm really happy to welcome again my collaboration partner and also co-host, Simon Voss.
Yeah, also thank you, Max, for inviting me. And yeah, also thanks to our audience for showing up here. My name is Simon Voss. I'm touring for about 1 year now, Europe with this little van, electrically, battery-driven, of course, to explore the competences and the potential that our European ecosystem has. And with that, I think TraWeBa and the Battery Expedition are joining forces on this. And of course, this all only matters because we have innovative companies that have innovation to show, such also as in the Battery Spotlight event today. So next slide, please.
Yeah, because while we still wait for people to join in, I would like to highlight two. Now you can see the next slide.
Yes.
To highlight two events we have coming up, and that is the Battery Investors event on the 4th of May, and then the following day, the TraWeBa Congress. And in both of these events, we will discuss a similar topic. And for this, let me show you one slide. What you can see here is the matrix of companies and investors. And as you can see, there are a lot of possible matches, and some of them are highlighted. And the highlighted ones show that this is potentially a really good fit. And that was done with the power of AI. And that's what we will discuss. And also what we will use. We will use this on the Battery Investors event to bring together companies and investors more efficiently. And we will discuss this at the Congress the following day. How can networks use this technology to work better together internationally, and then, as a final step, how to better support the companies they are connecting. It is free of charge, and you're all very welcome to register, to join in. The first event is in English. The second one is then in German, the TraWeBa Congress. And of course, for the Battery Investors event, you can join in, but we are really limited on places we can give. So for this, feel free to apply to register for the event, but the places for startups and companies, we still have some spaces left, but not so many. So if you're interested, hurry up. But with no further ado, I think it's time to move over to the main part of today, and that's our speakers. And Simon, please give us a short overview of what we can expect of today's speakers.
Yes, sure. Thank you, Max. So today we do a kind of a diagonal cut through the battery value chain, looking at battery materials, battery production, but also going into analytics and into the operation of battery systems and their supervision. So I think therewith we have a good understanding how the whole production side works, but then also on closing the loop with the final presentation on pre-mobiles, for example, with the recycling. That said, I would now like to welcome Fabian and Schütt. But before we jump into that, a short note on if you have questions, please hold them for a second until the pitch is over. It takes about 4 minutes, and then state them in the chat afterwards, or just raise your hand and speak into the mic. So with that, Fabian from UniverCell, he's the director of technology at UniverCell. And UniverCell is really special because it's one of the few companies that actually know already in Europe how to manufacture electrodes and build them up to full battery cells for various applications. So without further ado, Fabian, I think you can way better explain than me. Go ahead.
Yeah, thank you very much for the introduction. Very happy to be here today representing UniverCell. So what we saw over the last years and still see today is that Europe's massive capital-intensive projects have all mostly failed or have their operational challenges. And today, what I want to show you is how we at UniverCell approach this differently, how we choose a more organic growth path to become a European cell pioneer and hopefully in the future, one of the leading cell manufacturers of Europe. So UniverCell today is a company focused on the development and manufacturing of cells and electrodes for special applications. We were founded in 2019, and today we have a production capacity of already 1.5 GWh in electrode production. We are currently 85 employees. Actually, now we are already 90 employees because we are now growing. We have one headquarter in Flintbeek, which is close to Kiel, and we have another production facility now in Kiel in 𝗕𝗫𝗁𝗲, where we will ramp up our cell production over the next months. And then we have offices in the US and South Korea. And what did we do differently? What was the idea from the beginning is that we are not focusing on this large automotive market because it is too competitive and too price sensitive, but 90% of oil manufacturers focus on that market. And therefore there was a shortage for other markets, which we call special application markets. So we are focusing purely on applications such as power tools, e-mobility, e-aviation. For example, drones are becoming more and more of interest due to the geopolitical situation. Aerospace technology, more and more satellites are getting into space day by day. And how did we do this? How did we build up cells now for special applications? Starting in 2019, we just started with a pilot line in an R&D laboratory. And that is the main essential point. We did the first step at that time. We learned how to code electrodes. So we understood how to build, mix the slurry, how to do the electrode coding. What is a good electrode? Before we invested into the next step, into the mass production of a pouch cell line. By which we can then also verify these chemistries, starting developing our own chemistries, doing development projects with customers, and thereby getting more and more know-how. And even in 2021, we were already cash flow positive, which is, I think, quite unique for a battery company in Europe, without a big invest in the back. And thereby we could increase our coding capacity in 2022. So there we installed a mass production line also to learn and get the know-how how to produce electrodes on a larger scale. And thereby we could deliver electrodes to OEMs, not only 1,000 meters, but for example, tens of thousands of kilometers for their programs. And then we wanted to transform. We wanted to become from an electrode manufacturer, we wanted to transform to a cell manufacturer, and therefore we launched our cylindrical cell program in 2023. We developed the chemistries, we developed the housing, so we knew we needed some unique selling points so that we can be competitive to the Asians. And in 2025, we then acquired our new production facilities, which we are now ramping up. So what we basically did, step by step, first learn how to code, then build cells, for example, pouch cells, and now we are transforming into the cell manufacturer. And what makes our cell special? We have a lightweight housing, so it's based on aluminum, not on stainless steel. Thereby, our cells are pretty lightweight and have a very good gravimetric energy density. We use a tabless design, and in the future, we are also going into the direction of dry coating, where we invest now quite a lot to understand the process, but also they are doing it organically, understanding what we need to do and then scaling it up. And where are we doing that? This is our new factory. This is actually an old newspaper printing facility. So it was used for roll-to-roll processes, and now we use a building which was used for an old technology nobody needs anymore, and now we use it for this new technology to produce cells inside this facility. And we will ramp this up more and more next year for 40 million cells, and in 2030 for up to 150 million cells per year. And how did we finance that? Well, the first step now, we closed our funding round in 2025 with 30 million. And believe me, this was very challenging in this time of the European battery market. So I'm very proud of our two founders that they made this happen. And now we can finally go the next step, ramping up everything. Yeah, and thereby we hopefully not even soon as we can transform also from the cell pioneer to a real cell manufacturer and hopefully leading one in Europe. Yeah, and with that, thank you very much, and let's energize the future.
Thank you, Fabian, for the inspiring talk and insights. Let you allow me one comment on the investors. So that will, for two reasons, will be way easier in the future for you, or three reasons actually, because you're progressing step by step as you outlined in your history chart. The second, the IAA is, I think, sending now a very strong signal into the industry. And third, we have the battery investors event coming up. That is also, of course, a good opportunity to leverage conversations and get deals going.
Yeah.
Okay.
Could be that we see each other there.
Yes. So, questions from the audience. Is there any? Let me check the chat really quick. So if not, I have one. Yeah, I think the audience has not waken up so far. So let me ask the first one. You're pioneering on electrode dry coating. I mean, so many companies have tried this so far. The development is going for about 10 years now. Can you talk a little bit about the breakthrough moment and what it really took in order to solve the puzzle? Was it a pure engineering point? Was it also the economics? Was it on the materials side? Was it just the process engineering? What helped you on really progressing there?
Yeah, actually, it all comes together. It's a lot of engineering, but what helped pretty much is that the understanding of the wet coating process, you can transform it somehow. You can take this knowledge and you can utilize this knowledge, at least for like the pre-powder production. And then what is, I think, quite essential to have people which are not only have idea about chemistry, but who are more in the middle. So for example, I'm a material scientist, and I think for dry coating, material science is really good because it brings this technical expertise together. And we also had a partner which built with us together the dry coater. So we could also really dive deep with him into the development and not just use what is on the market, but bring in our own ideas.
Yeah, I think that is to be emphasized. That what I also noted during my visit on the battery expedition at your facility, not the new one, but the old one still, is that you're really building up machine know-how, right? You're not a machine manufacturer, but you're kind of an engineer on the machines you buy, really customizing them. I think this is something we may want to underline here.
Yeah.
So one final question from the audience. Julian is asking, what materials are you innovating on?
The principle, we can code everything. So I forgot to mention, we coded more than 1,000 recipes so far. So last year, 200 recipes on the pilot line. Of course, less on the production line. And now the first cell which we will produce is based on NMC and silicon carbon composites. So we are going for high energy design. And later on, we will also have a cell for heavy duty and also for high power, but focus is on NMC, SEC.
Gotcha. All right. Any plans on sodium on the horizon?
Of course, we are also in the ZIP.de Entwicklung in this big German project. I'm actually in the core team. So we are also looking into sodium-ion batteries because there's also some interest.
Okay, good. So who wants to have battery cells from UniverCell, please approach Fabian through the chat or otherwise. And I think since we stick with materials, our next speaker, Max, you can introduce him, has something to offer there as well.
Yeah, for the next speaker, I would introduce that understanding is the key to improvement and that analysis is the key to understanding. And with these words, I'm really happy to introduce the second Simon of today's session, Simon Goeckler. He's from 𝗕𝘁𝘁𝗶𝗵𝗵𝗵, the business development manager there, and he will talk about the 𝗕𝘁𝘁𝗶𝗵𝗵𝗵 solutions for integrated analytical solutions for the whole battery value chain. Simon, I'm really happy that you're here, and the next 4 minutes are yours.
Thank you. So I hope you can see my screen and hear me so far. And yeah, I'm happy to be here and talk a little bit about enabling the science of future batteries for a cleaner and safer world. And just let me show you this slide quickly, because I don't know how, if everyone knows us, to give you an idea of our global scale, breadth and depth. So our strong industry track record and reputation, which provides compelling proof points about the whole collective. But now let's look to the battery value chain. So we really serve the battery value chain with advanced analytical solutions from research to recycling. So really from the beginning to the end, also adding mining, then again, if you close the loop from recycling, with market-leading technologies. So really from spectroscopy, electron microscopy, trace elemental analysis, could be chromatography as well, mass spec and rheology, even extrusion systems for lab production or trials, software solutions, and much more around the whole lab and production scale. But now let's take a look into the R&D space. So building on our coverage of the whole entire battery value chain, it's really for today's conversation, discussion about the R&D spot, where material decisions are made and performance is defined. So here, it's all about gaining deep insights in what's happening inside your battery. So from lithium distribution or sodium, as discussed, and interfacial chemistry to structural changes during cycling or early signs of failure, like growing dendrites inside the battery or impurities you might face there. So by combining complementary techniques, so these are only a few examples we can offer, so like SIMS or spatial chemistry, or the ICP for the trace elemental analysis, or GC, GCMS, if you look into the electrolytes and degradation, even for the rheology, as mentioned, for the formulation, we can connect the fundamental understanding with process optimization, and ultimately this allows researchers to develop more stable materials, better coatings, dry coating as well. For example, with the extrusion systems, we did some trials with the KIT on that, and accelerate innovation with confidence. And to stay at the forefront of the battery innovation, we really work closely with leading KOLs, key opinion leaders across the whole global battery ecosystem together, like institutions like the UC in San Diego, Imperial College in London, all the Fraunhofer Battery Alliance institutes, or many of them in China, even also the MEET in Münster, the KIT in Karlsruhe. And these collaborations give us direct access to the latest R&D challenges in materials and cell developments, and so allow us to co-develop together with those people advanced analytical workflows together with our partners. And the outcome is not only better and more relevant in meaning of solutions we can create, but also strong in validation through high impact scientific publications we can create out of that. And I want to give you quickly inside what we did here as an example that you understand what we are doing. So for example, with Shirley Meng from this UC from San Diego, our electron microscopy division, they tackled a key challenge in the battery R&D spot and how to handle highly air sensitive materials without altering them during the preparation and analysis. So Shirley Meng and our R&D team, they co-developed an inert gas sample transfer workflow, so integrated in a glove box and then the transfer to the electron microscopy. And the result was samples that stay fully protected and you get the true material information and no artifacts from air exposure, for example. And this is really critical for reliable battery research. Another thing, because we are not talking about US, it wasn't one example is, Europe as well. So we were involved in the full map or are involved in the European full map project as in the consortia where we got the grant for 2.5 million, really working together with all those companies and consortia partners you see here. Moving forward also in the electron microscopy, but also in the XPS workflow spots and also our ICP-OES solid material sampling, where we improve here together with Mead in Münster at this stage. So the final slide is just if you want to have a little bit more information about what we are doing in batteries, feel free to reach out to me or scan that QR code, go to our landing page. That's it.
Thank you, Simon. Well on time and good overview. Maybe let's start with a question about what's your you talk now a lot about how you use your analytic techniques in the lab. Are you actually focusing just on the scientific research part, or do you also supply the industry?
No, it's not only the scientific part. It was really, you see that it's a wide area in the battery value chain. I had to pick one example. So I was focusing on the R&D spot, but we are really going into the production as well. So we have also inline measuring systems, for example, for looking for the coating and the calendaring lines in the product lines. We also want to establish systems that are at line to do, let's say, the quality control, not only developing new materials, but enabling also the production people to get their results quickly, reliable, also perhaps in a validated environment that you really can rely on what you get for quality control and reduce scrap rates, for example. And then we go even to the recycling people, talking with them how they can get better recoveries, higher purities in the materials. So that's really covered all.
For me to get a better understanding, if you would how much of your products go to the industry? How much is the research part? Are they equal? Is one a lot higher than the other?
It depends a bit on what we are talking about. If you would say, so the products for the R&D are more price intensive, I would say, but the number of instruments is less. So if you look to the industry, there would be some simple gas chromatography systems, some simple ICP-OES systems, but in a higher number, because they would have to put like 5, 6, 7, 10 systems to their lab. But if you go to the Mead, they will just have like one big XPS from us, which is sure not perhaps so cheap, but they don't have like 5. So I think in total, I would say if you look at the whole budget, it's perhaps 50-50.
All right.
If you look at the numbers, the number of systems is higher in the industry and less in the R&D spot.
Okay, yeah, I think it's a nice perspective. It shows that industry and academic research, they need each other. They scale together as well. All right, I think we've time for one quick question, if one of the audience has one. Otherwise, let me follow up with the last one, and maybe just really quickly, because it's a question you can, of course, talk a long time about. Do you see like a tendency, like which type of analytic technique is most requested right now? Or can you see that at least?
Oh, very good question. So I think which is needed most is everything that at the moment reduces scrap rates. So looking into magnetic impurities, getting rid of them, especially the sampling. So the analysis itself perhaps is not so much the issue. It's more like how do I get the sample ready for a quick result. I think that's the biggest issue at the moment, and that's something where we really want to improve and discuss with people from production, from universities, from the field to learn how we can solve that together. So I think QC is with sample prep is really of high importance at the moment.
All right. Thank you very much, Simon. And with this, move over to Simon.
All right. So from analytics, we come to materials that we also talked a little bit about in our first keynote, but not about the electrode material as such, but the electrolyte that is in between. And it's kind of going back to my research times and when I wanted to order electrolyte, and I was given a name, and that name was Elyte back in the days, which was one of the first startups offering custom-made electrolyte for research. But by now, Elyte has scaled a lot. And with that, I would like to introduce Sebastian Roolfs, who's also co-founder of Elyte, and we'll talk a little bit about the European backbone for electrolytes. So Sebastian, the stage is yours, and yeah, let's go.
Simon, yeah, thank you very much. Can you hear me? I think now it's
Yes.
working. Oh, yeah, thank you. Good afternoon. As Simon said, my name is Sebastian Roolfs, and I'm one of the co-founders of Elyte Innovations. So in the next few minutes, I will show you how Elyte, I think as the only true European full-service partner for electrolytes, turns electrolyte innovations into scalable industrial solutions and what we offer our customers and partners also beyond that. But first of all, let me give you a short overview of some key facts about Elyte. So as I said, Elyte is the first and only pure European partner for the development and manufacturing of electrolytes for innovative battery technologies. But the most important thing here is that we don't only work on lab scale. We already operate industrial series-ready production with a capacity of up to 20,000 tons per year. With our locations in Karlsruhe and Münster. So we stand for European technology, short supply chains, which is very important when it comes to electrolyte, and very high quality standards. Yeah, Elyte is not only focusing on lithium cells, but also for sodium-ion technology, supercapacitors, and next-generation cells concepts. For our customers, this means, of course, more flexibility because they have one partner who supports them with multiple technology platforms. Yeah, but across all these technologies, one thing is really, really critical, and this is how we at Elyte are integrated along the value chain. And this is exactly what makes us a very strong European partner, because we have already implemented a full end-to-end approach. We cover the full entire electrolyte value chain, from raw material sourcing and development to high-quality series production and even initial recycling concepts. In practice, this means for our partners and customers, fewer interfaces, fast deliveries, of course, and lower risk. Nevertheless, production capability is absolutely key to competing with established electrolyte companies from especially Asia. To meet this challenge, Elyte has built a fully automated, flexible, and scalable manufacturing process. And this allows us to combine premium quality with, and that's really important, competitive cost structures. And we are and this is enabled by one of the most resource-efficient electrolyte manufacturing processes worldwide, with which we already proved, and why our production process is getting funded from the KfW and Umweltinnovationsprogramm. So, and of course, once you scale, quality becomes the real differentiator. So when it comes to series production, there is no room for compromises. And that's why we rely on a 100% batch control, full traceability, and fast responses whenever an issue arises. So our goal here is very simple. We want to deliver consistent, high-quality electrolytes without any compromises. Our R&D center in Münster plays, of course, a central role with our own cell testing infrastructure, our data-driven evaluation, and structured product development process. We help our customers bring their cells to market safely and quickly. And one thing here is very important. Our joint development work is always built on clear frameworks and confidential collaboration. So I think this is a big differentiation to our Asian competitors here. And finally, we extend this approach through a set of supporting services. We offer services such as workshops, compatibility studies, post-mortem analysis, and most important, our benchmarking studies, which we are offering especially for the chemical industry. And as a result, our customers can resolve issues, of course, faster and bring their products to market sooner. So, in short, our ambitions at 𝗕𝗕ite goes way beyond just supplying electrolytes. We aim to be and remain the #1 full-service electrolyte partner for the Europe's battery industry. Yeah, thank you very much, and now I'm happy to answer your questions.
Yes, thank you, Sebastian, for elaborating on the services that you provide to our industry, because as we learn, not just a product, but a whole, it's a service, it's a system that you provide. And maybe let me open up the discussion with one question, because you mentioned electrolyte recovery and recycling. Can you explain this, how this would look in practice, and also the business case behind it? If it's really an economic business case, or is it just for the sustainable sake and the environmental friendliness? So can you explain this whole closing the loop a little bit more?
Yeah, that's a really good question. So we are really in the beginning of this, to be honest. So, but of course, it has a big importance because the electrolyte contains lithium, and not as beside the solvents, which are also really important to gain back. The electrolyte contains lithium in the salt. So for the industry, it's really important to gain it back in a really good recycling process. But to be honest, I'm not the real specialist in this case. We have a task force in-house, which is always also working within a public funded project. I think it's called Extreme. And we're making really good progresses within this project. And we also plan to set up a little pilot plant for recycling the solvents. But that's it at the moment.
Okay, gotcha. But it's really interesting to see, right? Because what I wanted to kind of pinpoint at is Europe is, and you mentioned also Europe is evolving slower. Because it's a new industry, we're getting into this game, but we're really doing a really good job. You said also that you're kind of leading the game in terms of quality, and also from a systems perspective, at one point the whole loop closes, and then I think it's a really, really efficient and effective industry delivering new technologies. So let me check the chat one more time before I answer the next question. This is on the previous talk, I think, on the dry coating. Yeah. So in terms of your market fit, what is the prime selling point for 𝗕𝗕ite? Is it the quality? Are you also competing in terms of economic metrics? Where are you really excelling in comparison to the competition? And also, does it go beyond Europe already, or would you say like your market is really Europe focused?
Yeah, so at the moment, our main USP, to say it like this, is that we of course we are European. So when it comes to the value chain, we have a good position in the battery value chain, because the electrolyte has sorry, what is it called? Mindesthaltbarkeitsdatum.
Expiry date. Yeah.
Expiry date after 6 months. So if you import from Asia, there's always a little risk. But also we have we are focused. We have a very big know-how inside. So we have 3 scientists which are working since over 10 years, only focusing on the electrolyte. So we can offer for also innovative cell technology always the right solution. So we are focusing on offering the customized solution for our customers, so that we can guide them from the development into the serious production. So for us as a European partner, of course, it's a big advantage because we are talking the same language like our customers, and they rely on our confidentiality. Yes.
Yeah, gotcha. So yeah, a lot of support and guidance along the innovation pathway. This is what I take away from this. Good, Sebastian. Thank you very much. Unfortunately, the time is up, and from material excellence and performance, we come now to operation excellence and performance. And Max, I would like to hand over the mic to you again.
Yes, thank you. And yes, I already mentioned the importance of analytics, and we now move to what can be done by battery diagnostics. And I am really happy to introduce the third Simon of today's session, Simon Schwab. He's CEO and co-founder of the company Electrolyte. And Simon, I'm really interested in what you can tell us about the diagnostics of battery cells, and the stage is yours.
Yeah, thanks a lot for the invitation and for the introduction. So, as you know, batteries are quite often the most expensive component in many applications, and unfortunately, they age over time. And during aging, the true state remains frequently unknown. And that's why diagnostic models are essential. And because you need them to unlock the true power of batteries. But as we've seen in the market, there are three limitations why batteries are still wasting a bit of their potential due to the usage of current diagnostic models. Firstly, there's a lack of accuracy because existing models running on the battery management system, the BMS, or in the cloud show often deviations of up to 10%, especially for LFP with the hysteresis. Secondly, there are, for running them on the BMS, limited computational resources. So AI models are too complex for the BMS integration, and the cloud dependency causes high costs. And thirdly, quite often the monitoring of the batteries in operation is only limited to pack or module level, and invisible individual cell states promote a poor balancing where the capacity only is decreased because of the worse balancing. And to sum up these limitations, in worst case, this leads to an unnecessary downtime, but definitely to an inefficient battery usage and a loss of value over the entire life cycle. To solve these limitations, we found a spin-off 𝗕𝘁𝗁𝗵𝗵𝗵𝗵, a spin-off from Offenburg University in southwest of Germany. And what we are offering is a collection of algorithms for the monitoring and diagnosis of lithium-ion batteries using real-time operando battery operation data. Therefore, we fetch the measurement data, which is already there at every battery from the BMS, voltage, current, and optional temperature. And out of that, our algorithms calculate state of charge, state of health, also properties on single cell level, and can, for example, quantify cell and module imbalances in order to enable strategies to recover pack capacity, which is only limited by a bad imbalance. And with our approach, we offer a higher accuracy with, at the same time, lower computational effort compared to the state of the art. And our patented models can therefore be operated as a first product, as a software on a server in the cloud with a visualization via a dashboard, or directly embedded in the battery management system close to the hardware. But what's the reason behind that we can offer higher accuracy? This lies in the methodology we are using to quantify those values, state of charge, state of health, and so on. Because our new USP is the usage of voltage-controlled battery models, what differs us from the state-of-the-art modeling from competitors and from standard approaches. Because as in the state-of-the-art approach, you use a current-controlled battery model where the current is input for the model. You calculate out of that a voltage, and typically via a Kalman filter, you can quantify SOC, SOH, and internal resistance. what's related with high effort of settings and parameterization, and knowledge of the battery is required, for example, via pulse measurements. We were then the first who turned that approach upside down, use a voltage-controlled battery model with the voltage as an input, calculate out of that the simulated current, and without filter equations, we can quantify SOC, SOH, capacity, internal resistance, as well as the OCV curve, which is a fingerprint for each battery, using highly dynamic battery operation data without artificial low current cycles, for example. And we could demonstrate in several scientific publications that this approach has several advantages for us compared to the state of the art. For example, a lower setting effort, a higher sensitivity of our model parameters, which as a result of that can guarantee us more accurate results. And we don't have influences of current inaccuracies, as a basics of physics, voltage can be measured more accurate than the current. So to sum up that, by offering a higher accuracy with our new methodology, this higher accuracy in quantification of SOC and SOH always lead to maximum performance of the battery and to maximum revenue generation using your assets. So if you're also tired of unreliability caused by inaccurate diagnostic models, please feel free to reach out, and I'm looking forward to your questions now.
Thank you very much. And maybe let me start with the first question. And then if the audience has some, just unmute yourself, raise your hand, unmute yourself, ask the question, or of course, write it in the chat. You mentioned that one of the problems is that conventional methods right now don't have the single cell diagnostics. And there, my question, you said that you can do this on cell level, but how can you address a single cell in a pack or in a module?
Well, we do have the measurement data on single cell level. For example, the single cell voltage. If you're thinking on the pack, there are some serial strengths, some parallel strengths, and over the serial strengths, the current is the same. That's why current-controlled approaches miss their analytics, and the voltage is still different in the serial strength. And by using this voltage as an input, we can quantify state of charge, state of health using this measurement data.
Right. And do you need, what's your computational need for this? Can you run this on the BMS, or you still need the cloud infrastructure?
No, that's an advantage of this voltage controlled approach, as we don't need these filter equations, which are typical in Kalman filters for this state of charge and state of health quantification. As we don't need that, we can also run our models directly embedded on a BMS. And we could also demonstrate that with some partners where we could run those models on a BMS with very low computational effort, quantify SOC and SOH directly embedded in the hardware. So we offer both. On the one side, algorithms running in the BMS, but also the cloud-based analytics, which is maybe for operators more interesting to have the values in a dashboard and to see the trends of aging, for example.
All right. We have one question. Thank you. We have one question from the audience.
Yes.
Patro, please.
Yeah, thanks for this interesting approach. You said it is more accurate in terms of SOC and SOH. Can you tell us a number, a percentage? What accuracy can you reach in SOC and SOH?
That's a very good question. That depends on the benchmark you'd like to use for quantification of accuracy.
For example, let's take the capacity, the nominal capacity at the beginning of life. Take that as a reference value, and then which percentage could you then what's the error in percentage of the nominal capacity?
For beginning of life model compared to Coulomb counter, for example.
No, I mean, what's the error you have when you determine or when you estimate the capacity, let's say after some years of operation, what's the error compared at a percentage error with respect to the nominal capacity? Is that some number you can give us?
Well, if we would calculate the capacity after some years, then the battery has aged and our benchmark wouldn't be the nominal capacity, then the benchmark would be the capacity calculated at low current conditions in a lab condition, for example.
Okay, then take this. What's the percentage error that you can reach?
Then it's typically below 1%.
Oh, that sounds really good, yeah. Thanks.
Depends also on some other factors. Do we also have temperature data? Do we have OCV curve? But yes, depends on sample rate, but that's what we can offer.
And to this approach, is there a keyword that I could Google to understand more about the method?
You could contact me and then I could send you the publications, which could give you some more insights into the method.
Okay, I'll do that. Thanks.
All right, perfect. And with this, we already have to move on. There's one more question in the chat, but maybe Simon, you find the time to answer it directly in the chat, because now it's time for the next speaker, and therefore move over again to Simon Voss.
Right. Thank you, Max. You have to say many times Simon today, right? So we also have arrived at the end of our value chain, or kind of at the pivoting point to closing the circle, meaning the battery recycling. And Sushant and Patro is today talking about delivering value to the lithium-ion recycling by means of providing recycling production equipment or recycling equipment, so the machinery for it. So I'm looking very much forward to welcome him on stage. He's the Sales and Business Development Manager at 𝗕𝘁𝗿𝗵𝗵. And with that, and without further ado, stage is yours. I think the presentation is on. Yeah. So we can.
Okay. So finally, not one more Simon, but Sushant this time. And as we said, when we talk about the future of battery recycling, we are really talking about the future in terms of industrial resilience, critical minerals, and critical circular manufacturing. It is no longer an environmental issue, or it is far bigger challenge and creating a supply chain issue, an energy transition issue, and more of a competition issue also. So the whole world needs more of these critical minerals, which needs the process and technology knowledge to meet those challenges. And when it comes to recycling technology, there are several challenges. First, the battery diversity itself is an issue, with not only various types of lithium-ion batteries, not only in terms of chemistry, but also in terms of the physical shape and size. Then comes the safety and fire issues. Third, collection and reverse logistics issue of ensuring the volume required for a recycling plant. Fourth, the essence of recycling as an industry should be based on economics and not only on regulations. And fifth and final being the purity and the product quality required to ensure that the loop is getting closed. So the next obvious question is 𝗕𝘁𝗿𝗵𝗵, what, who, and where we are. 𝗕𝘁𝗵𝗵 is a battery recycling value and what it brings to the value in the recycling value chain. We are a 100% subsidiary of SMS Group based out of Germany. And SMS Group as such stands as a benchmark for engineering excellence and combining over a century of technological experience and expertise and building plants globally, and currently operating from more than 100 countries. So the company delivers end-to-end solutions from design and engineering to commissioning and lifecycle services worldwide. And 𝗕𝘁𝗵𝗵 positions itself on very similar DNA with a very strong focus on sustainable technologies, enabling customer to enhance productivity, quality, and environmental performance. the holistic solutions and the integrated approach is being very well recognized by the industry through various awards, further reinforcing our drive to innovate and to develop sustainable solutions. The industry does not need more concepts. It needs mature technology, robust process design, and scalable plant engineering backed by strong project execution capabilities that can turn these challenges into facilities that perform at industrial scale. The photographs that you see on the screen are the actual photographs of plants for Mercedes-Benz at Copenhagen. So already plant operating at scale. And since Promovius offers a one-stop partner for complete recycling solutions that cover the entire value chain. So if you wonder why Promovius again, the answer is very simple, because it combines the engineering depth, industrial credibility, and a clear sustainability mission. It is helping turn battery waste into valuable resource stream. It is de-risking the supply chain challenges and the next generation of battery recycling infrastructure. Every ton of battery material recovered through recycling reduces pressure on virgin mining, cuts waste, and supports a more circular economy. This is not only good for environment, but is also good for ensuring supply security for Europe and the world's industrial independence. Promovius is not just part of the battery recycling future, it is actually helping it build it. If you have any questions, do let me know, or you can contact me at this.
All right, Sushant, thank you very much. This was very elaborating. Getting a better understanding of what it means to scale recycling. If I understand it correctly, your plants are machines that you provide are looking specifically at hydrometallurgical recycling, right? They're generally two pathways, like the parametallurgical and then the hydro one. And maybe you can explain a little bit where you're located, what the benefits are. And you just mentioned it also in terms of sustainability and water. I think you run a closed loop. Maybe you can explain this a little bit for our audience.
Yes, for clarity, we are a technology provider. We don't operate a plant. Of course, for building this know-how, we did build a plant. We did operate it at commercial scale before going out to market as a technology provider, so that we have hands-on knowledge of operating our plant before becoming a technology provider.
Yes.
So that's how we moved into the scale plant with Mercedes-Benz. But then we do provide from dismantling, discharging, shredding and beneficiation to hydrometallurgy. And when we talk of hydrometallurgy, one of the biggest challenges today is the waste materials, especially the sodium sulfate and other waste, which becomes a challenge to handle. And that's where the maturity of our process comes into picture, where we ensure that the wastes are manageable and can be handled easier. And we avoid those critical waste like sodium sulfate out of the circuit, so that we are completely free from those things.
Okay. There's one question picking up on this from the chat. Andre is asking, what about LFP chemistry? Is it processable with your plant?
Yes, yes. LFP by itself, or even the process is such that we have ensured that it could be managed with a mix of all kinds of lithium-ion batteries in any proportion.
Okay, can you explain this a little bit more in depth so that we can understand how are we solving this puzzle? Because I mean, also on my visits at other plants or like actual recyclers, I mentioned like sorting is quite important for many of them. You're saying you can mix them. You say, look, you can hydrometallurgically recycle LFP. So please go one level deeper so that we understand it.
This is the reason why we are saying the technology is evolving. In our phase one of our product, we realized that this is the challenge the customer faced. So we had to work on it to find a solution to make sure that we avoid the manual sorting and the manual effort which is required to sort and to run the plant in campaigns. Then you are not efficiently operating your plant. So knowing the challenge, we ensured that the plant is designed, the process is made such that if you are unable to segregate, the process is ready to accept any mix of lithium-ion battery provided they are lithium-ion battery, and the variations could be in any volumes. Of course, it does make sense that if you have more NMC, you have more critical minerals to recover. But then if it is LFP mixed with them, we are still using it to the best advantage, because LFP also has got iron, which is used as a reductant when we are treating the in the hydrometallurgy. So in a way, the mix helps also to reduce consumption of reagents and still being efficient.
Okay, but you also can recycle pure, like
100% LFP also.
LFP. Okay,
100%
so not
LFP
a
is
mix.
possible. Yeah.
Okay, good. So
And
Andre,
still
I
be
hope
economically
this,
viable. That is
I
more
hope this
important.
answers your question. Okay, Sushant, thank you very much for giving the direct answers. I think we have a good understanding and also see how the technology is evolving on that end, right? To build the European battery ecosystem. Thank you very much. And yeah, then I think we're already at the end of the session. And Max, do you want to land this plane?
I want to, before I end it, I have one more question to him, because I just came back from the Hannover Messe, and there was a lot of robotics, and especially the humanoid robotics. They are popping up right now. I mean, I think there's a big business case in it. But the question there was, can you use them for the recycling, and especially the taking apart the battery? Is there a real use case there, or should you just use the like established machineries, which are more which are not
no,
as flexible?
For dismantling purpose, it can be used, provided there is some information availability of the kind of batteries they are made, because our data has to be fed into the system first. Or if there is a regularity of the kind of batteries, then we are able to ensure that the robots can work. But if the battery itself changes so often, then getting that original manufacturer data is quite important. But practically possible in future.
To see them in a battery recycling lab.
Yes, it should be possible.
Thanks, and yeah, for the last answer of today. I think with this we really came to an end of today's session. Let me just briefly share my screen again. Because before I want to thank all of you for joining today, I want to highlight that we of course do this next month again. So if you want to join our next Battery Spotlight session, it will be May 28th, again, same time, 4:30 CET. And if you have an innovation of your own and you think, I want to present that as well in this format, then feel free to reach out to us, especially reach out to Julian Rempeling. He's doing a marvelous job in coordinating all the speakers, preparing this event. So thanks, Julian, for your work in the background. And so yeah, with this, I finally come to the end, and thank you all for attending. Thank you all for listening, and especially the speakers for your really nice insights in your innovations. And thank you, Simon, for being a really nice co-host again. And yeah,
thank you, Max.
I wish you a nice evening.
All right. Yeah, also from my side, thank you very much. It was fun again. I'm looking forward to the next one. And in the meanwhile, if we meet up in Berlin, I'm looking forward. So have a great evening.
Thank you to all the Simons.
Thank you.
See you all again next time.
Thank you.
Bye.
Bye.